You're listening to the Future Tech Podcast with Richard Jacobs. Future technologies such as artificial intelligence, stem cells, 3D printing, gene editing, Bitcoin, blockchain, the microbiome, quantum computing, virtual reality, and exploring space are much closer than you might think. In fact, many early versions of these technologies are in play right now, and the companies that are using these technologies are the focus of this podcast. My goal for you, the listener, is to learn from these podcasts. You may very well learn something that may change the course of your life for the better, steer you towards a new career, or give you insight into addressing a thorny medical problem. Remember, this podcast and its content is informational in nature only. No medical, tax, legal, financial, or psychological advice is being given. If you've enjoyed the podcast, please listen, subscribe, like, and tell your friends about it. Thank you. Hello, this is Richard Jacobs with the Future Tech and Future Tech Health podcasts, and I have Rodrigo Martinez. He's the CMO for Veritas Genetics. The website is veritasgenetics.com. So, Rodrigo, thanks for coming.
My pleasure. Thanks for having me.
Yeah, so tell me, what's the premise of Veritas? What do you guys do?
Well, we saw about 5 years ago that it was time to make a big bet on the genome, and at that point, sequencing someone's genome was probably somewhere between $10,000 and $30,000, depending on who you would go see or how you were able to do it. And we thought, look, it's time to figure out a way to drop the price to less than $1,000. Very high quality DNA test that would be useful not just for interesting things like ancestry, etc., but actually with medical insights that can be useful in making better decisions about your health, and a test that both consumers and physicians could order. So we started Veritas. A few founders come from the Harvard Personal Genome Project, a couple of engineers, business people, designers, etc. And now we're on our fifth year. We have a couple of different products all around whole genome sequencing.
So this is for an individual person can go to Veritas and get their genome sequenced for about $1,000.
Exactly.
Wow.
Exactly.
Yeah, I've heard there's different levels of sequencing. Like, there's companies like 23andMe and places like that. And I don't know too much about it, but I know they do a certain level of sequencing. So what is that level compared to what you do, and what's the implications of both?
Yeah, there's a lot of misunderstanding out in the marketplace. So actually, the technology that 23andMe and Ancestry and others use is actually not sequencing. They use a technology called genotyping. And, it's a technology that has served its purpose. It's been basically the last decade, it's been used for most genetic tests. And basically ask questions in someone's DNA and to answers that you already know. So you create a chip with these little dots, and then you query particular letters in the genome. Say, do you have it? Do you not have it? Do you have it? Do you not have it? So it serves its purpose in terms of answering questions that you already know the answers to. You cannot use it to identify something completely new. It was also used because sequencing was much more expensive. So as the sequencing cost has gone down, there's a lot more interest now in doing genome sequencing, and you can do two types, either exome. Exome is the part of the genome that has proteins that code for instructions. So it's about 2% of the genome. And then there's whole genome sequencing, which is where you sequence the whole genome, and that's all 6 billion bases or letters. And that's what we do. Now, things are moving quickly towards genome because your genome is basically all genetic tests that you can do on yourself, right? So it's the interpretation of what you find out in that sequence that matters. So that's basically the main difference. And of course, when you have a genome sequence, you can go back over time as more scientists and researchers find interesting things about a genome. You can go back and search for additional answers as time goes by. So let's say you sequence your genome, in 2018, and 6 months later, there's a couple of new papers and research that identified some more additional genes in an area that you're interested in, say something like schizophrenia. And you can come back to Veritas and say, hey, can you find out if I have those variants and how does that change? How could that potentially change my medical approach to this? Sure, we can go and find that because we've already digitized your genome. So that's the main difference. You can't do that, by the way, with genotype. So, yeah.
So to be more clear, genotyping is looking at the exome part of the genome, or is it not even that?
No, genotyping is even less. So genotyping is depending on the chip you make. So you make a chip with a specific request. So I think the latest chip that 23andMe was using had something like 1 million or a little bit less than a million points. And that's about less than half of 1% of your genome. So it's a quite small. So we, for example, we generate more data in the genomes that we sequence and the information that we get from our customers in a week than all the data that 23andMe generated since existence for the last 10, 11 years.
Oh, wow.
Yeah.
So how many different assays or tests or associations, like do you curate all the scientific papers out there and see what science in general is finding out about, the genome and include that in your reports to people, or like what do people get with their report, and how many different things can they look at?
Yeah, so we have a very expert clinical team, if not the best, one of the best teams in the world. And so there's an established set of things that one can interpret today that can learn about the genome, and we include all of those. And some of them have to do with disease risks or some conditions that you may carry on that you could pass on to your children, or other different types of traits, etc. So we include all of that. And we're also now creating additional content that we think is important for people to have. And so there's more and more insights, if you like, that we are including based on the interpretation that our clinical team is doing. And then the next phase is basically using machine learning tools to analyze thousands and thousands and thousands of genomes, eventually millions, so that we can all learn more about what are the different relationships between the genes and the environment.
Okay, so what are some of the examples that seem to be most interesting to people, or that strikes you guys as super important?
Yeah, and the health risk side, there often people are interested in learning whether they have a precondition or they're at risk of a type of cancer, right? So we include that. There are other conditions that have to do more with mental health or with different organs. People are interested in learning about the BRCA1 and BRCA2 genes, which are, which influence the risk of you getting breast or ovarian cancer, and are also related to other types of cancers. So people are interested in that. Alzheimer's, your risk for Alzheimer's, etc. So all of these, genetics are not deterministic, right? There are only a few things that we know so far that show in your genes that actually determine with certainty that you will get sick. For the most part, it's really probabilities, right? They put you at a certain risk, which is the interesting part, because if you know that you are at a risk of a condition, for example, I am at risk of a condition called pulmonary fibrosis, which means that my lungs could develop these sort of fibrosis, sort of these little strings that prevent the lung from working properly, these fibers, right? I know what I can do to reduce that risk. I need to stay away from dust, from metal or stone or wood, etc. So I know the things that I can do. So I can adjust my lifestyle and just stay away from when I go in the street and there's a construction site on one side, I just cross the, I try to stay away from it, right? So I can do certain things in my life to minimize that risk. And I think that's the value of sequencing your genome, is you can learn certain risks that you have, and for many of them you can act upon, right? So people want to learn some of those risks that have a genetic component. The second category of things that people like to know are things they may carry, what are called your carrier status. These are conditions that you are not necessarily sick or you don't present any symptoms, but you could pass them on to your children. So people that either already have kids or want to have kids, they want to know if their kids are at risk of certain conditions, both in terms of what you bring with your genetics and then the other person, the partner, right? So that's the second category. The third one is drug sensitivities. So part of why certain medications work differently for you than they work for me is determined by our genes. And these are medications that many of us know, including, pain medication, et cetera. So in our report, we include a list of 170 medications, and we show which of those you might have an interaction with, with your genes, and therefore you should talk to your doctor about either changing the medication or adjusting the dose. So that's sort of a very practical, if you like, actionable insight. And then the last category are things more like traits and ancestry and other things that we do include in our report, but we're really emphasizing the actionable medical related insights in what we provide back in the reports to our customers.
Do you have to be careful in how you tell people to interpret the reports so they don't, get upset or freak out or feel doomed?
Yeah, that's absolutely. That's a great question. So two things. One, we've done a lot of work to create a report that I think, to my knowledge, is the best report right now out there, which is, it's web-based. It highlights, it gives you a summary of what are the things you need to first focus on. It doesn't give you all the technical scientific details right up front. It actually just explains, this is what this means. These are the risk factors. This is what you can do, for every major result. And then if you want the details, you can go on to the other tabs and look at all the details. So one is, how do you design properly a report? The second aspect is you want to have, I would suggest that we offer a genetic counseling. So if you are going to buy a genetic test, you want to make sure you want to have access to a genetic counselor or a professional that can help you if you have a question, right? And there are many companies out there that do not offer that. And therefore, we do, and we think it's really important to have that support, because some of these results can be very, not just medically important, but can be very emotional, right? And customers and or the physicians that are ordering the tests with some of our patients, they should have a resource and say, hey, let's have a call and have this explained, and what does this mean? And do we even talk about, do I have to talk about with my family members if I found a certain result? How do I do that, etc.? So we strongly believe that consumers should have the option of that support.
No, it makes total sense. What are some of the more serious results that are possible?
Some people, there's a very well-known variant, which the variant is basically a change in a letter or a series of letters in your code that predispose you to certain risk. There's a known variant in the ApoE gene that increases your predisposition for Alzheimer's significantly. So that particular variant, E4, is well known, and some people want to know, and some people don't want to know it. And partly is because there is no cure for Alzheimer's. There are some medications that can help delay it. But I would tell you that we know there's some research that shows that certain diets that are very iron rich might have a relationship with the onset of Alzheimer's, for example, or other things, right? So if you learn that you are at risk, for example, my dad died of Alzheimer's, and I wanted to know if I was at risk genetically, because you can also get it without having, the genetic root. And I don't have it, but I'm still very much aware of it and keep it in mind. So that's definitely one that people tend to know that there's an important one. And we have some customers that have shared some amazing stories with us where they learned they were at risk. They adjusted their diet. They made some other changes in their lifestyle. Even talked to the doctor about adjusting their vitamin regimes, etc. So that's doing something that could have some effect in delaying the onset of Alzheimer's. So if you can do that, why not?
Yeah, no, it's true. It depends on the person. Like, some people, I'm sure, don't want to know. And I kind of feel like that a lot of times too. But then again, a lot of people also feel power or feel a sense of empowerment by knowing, because they can at least affect the outcome and they know what they're getting into,
Exactly. Or at least they can actually do more research, right? I have two daughters, and if one of my daughters we all have predispositions for certain conditions, and that's just nature, right? So if I know my daughter has a predisposition for something, well, I'm going to educate myself better. I'm going to go find the specialists. I'm going to go find the literature, the clinical trials, everything, right? Even though it might be something there is no current cure for it, I want to be involved in it, right? Like I don't want to pretend that I don't know. So, and we're actually preparing now to launch a whole genome sequencing product for newborns. So we'll have that launch later on in the year, precisely for that reason.
Yeah, that's what I was going to say is, so this could be for someone that's, let's say, in their 40s and 50s, and they want to know, what they can do to improve their aging. And it could be for, a young couple that, are going to have children. They want to know if, they're going to produce children that have a certain problem or not. I mean, and then, like you said, for babies. So right at the outset, you'll know, how to improve your child's health, and the person themselves will know from an early stage, what's possible with their genome, or at least part of what's possible. So I could see a lot of different scenarios in which this will be really important.
Exactly. Yeah, that's exactly right. I mean, look, eventually everybody at birth will be sequenced. No question about that. Right? Like that's where we're going to go. When that is it 5, 10 years out, 20? It doesn't matter. The question is, what do we do from now till then? Right? Let's make sure we do it responsibly, that the information that we give back to the parents and the doctor, because at that point you're not giving the results to the baby, right? Is done responsibly and clearly, that they have the resources that they need to understand what are some of those results. And also, we only want to give back to the parents and the physician of a baby the things that are useful in the first, 10, 15 years of life, right? There's no need for them to know something that might come when they're 60. And maybe later on, when the child becomes 18 and becomes an adult, they might decide that they want to see the rest of the report or the rest of the results, right? Or they might decide they don't want to, right? But we know that where we're going is everybody will be sequenced soon. Not just because as the price goes down, because the evidence that having this type of information can be useful for your care is also increasing. There are many more studies now that show that having this information can be very valuable.
Yeah, no, definitely. Have you had examples where whole families have gotten sequenced and they've compared the data and looked at it?
Yeah, absolutely. I mean, we know from certain families that they have done this. Obviously, we're HIPAA compliant. We're very, very serious about how the security and the privacy of the data. So obviously, only the families that tell us as a group, hey, we want to do this, they're open with us, we know, right? Otherwise, we might not even know that we have a whole family, because the test orders have come in independently, right, individually. But yes, we do know that there are some families that are 4 generations and cousins, etc. And again, eventually when we're all sequenced, it'll be, again, we need to do it properly and protecting privacy, etc. I think, we're going to learn things that today we can't even imagine, right? We probably understand 1-2% really of what is in the genome, even though we can sequence it mostly all. We barely understand and know what a small amount means. Over the next coming decades, we're going to learn so much. We're going to realize that some of the things we knew were wrong or incomplete, and we're just going to learn new things about the relationship between genes and the environment, and genes to the environment, and hopefully we can act upon them and make smarter decisions about our whole biology, not just our health.
Yeah. Well, I know you can't name names, obviously, but are you privy to the data from, I don't know, the thousands or tens of thousands of tests that you guys have done? And if so, are you able to see any patterns or trends or any interesting things that jump out at you?
Yeah, I mean, so 2 things. Again, we follow, not just HIPAA compliance, but also what's called GDPR, which is a new regulation that came in Europe around data. And we also follow that, even though we don't have to in the States, we also follow it. So we're very careful about the privacy and how the data is managed. But I'll give you an example of a person that specifically wanted to tell his story and wanted to find out certain things about his genome, and that he actually let us do a documentary on it, etc. So the 18-time world record holder, free diver, William Trowbridge, is this fantastic New Zealand guy, and we sequenced his genome a couple of years ago, and because he wanted to know if there were some predispositions that he had for his sport and for his health, and he also wanted to know if other things. and we sequence the genome. There's actually on Medium. There's a couple of interviews with him and a nice piece that they wrote in three different chapters. And he did find some things that mattered in his case. And again, this is all public. A particular learning in his ApoE gene. Again, this one that is related to Alzheimer's. So that implies he needs to make changes to his training regime and his diet, etc. So, look, remember, we're 99.5% identical among all of us. But those few differences that we have, where the 30,000, 40,000, 50,000, 100,000, those few differences that we have can mean a lot. So finding those differences is part of the incredible magic of what we do today in genomics. I would call it almost magic, right? Like, look, if I would tell you, I think one way to explain this is if I tell you 100 years ago, hey, guess what? 100 years from now, we're going to find this incredible language that connects us with plants and animals and all the humans, and we're going to be able to understand it. And, you would think, oh my gosh, this guy's a poet and he had too much wine. There's no way you can imagine what we're doing today in genomics 100 years ago, right? And probably that's where we are today from 100 years from now. What we're doing now is gonna look like cavemen trying to do a painting in the wall compared to what we're gonna know 100 years from now. So that's part of the excitement, the exciting adventure we're on.
Oh, that's amazing. So are there any trends or overall, I don't know, things that you've been able to observe again amongst the thousands of samples that Veritas has looked at? Any, again, obviously no names, but anything that jumps out at you that surprises you?
Yeah. Look, I mean, some general things. One is we more than 10% of everybody that we sequence has a very important thing to learn. More than a quarter of the people we sequence have something useful and interesting and important medically. I'm not talking about other, ancestry and other stuff, right? So it's not like only 1% of people learn something useful. No, like it's about a quarter of the population at least. Everybody, all of the people that we sequence learn something interesting about their drug sensitivities, right? And whether they're taking that drug or not, at least they have that information now, right? And there's some other aspects like that. We have a lot of interest of our customers, both male and female, different age ranges, from 25 to, the majority of our customers are 25 to 55, right? But then, of course, we have 97-year-olds, 100-year-olds, we're constantly learning. Now, we also ask people when they sequence their genome if they want to participate in research, meaning could their data, without identifying them personally, be used for research, for us to learn more things? And a significant number of people, more than 70% of people, say yes, which is fantastic, because the only way we're going to learn more from our genome than what we know today is going to be by looking at thousands and thousands, eventually millions of genomes, and deploying some really, really strong and robust machine learning tools. And we've developed those, and we're doing it now with thousands of genomes, but we need to get to the hundreds of thousands and millions to really understand more.
Yeah, no, it makes sense. I don't want to be negative, but what happens if someone hacks Veritas and takes the data? Or what happens if a government tries to subpoena someone's DNA?
Yeah,
has that happened, and what would happen if they did that?
Yeah, I mean, all these questions are very important and very relevant. So we're a HIPAA compliant, if you like, entity. So just like Mass General Hospital in Boston, or any other major hospital, could any database could be hacked, right? We've taken all the precautions that we have, as you can imagine, in terms of encryption, in terms of not all the data sits in one place. Everything is on the cloud in different, across different servers, et cetera, et cetera. So we've taken all the precautions. Now, is any database safe from hacking? Of course not. None, right? Not just us, but anybody. We take as much precautions and as many precautions as we can, and we do what in order to do that. Now, the question sometimes is like, well, what would happen if
if somebody, and we get this question a lot, well, what if somebody gets my genome? I'm like, okay, let's assume that somebody can hack or somebody, you lose your password or something and somebody can look at your data or something. The first question that usually comes is, what would happen if my health insurance company finds out? So why are some people worried about their health insurance finding out the genome? And the answer usually is, well, because what if they find out that I'm not as healthy as I seem to be, or that I'm saying that I am, and therefore they might adjust my healthcare premiums, etc. Right? And it's a fair question. But sometimes they explain it this way, which is, look, if specifically for you, Jamie-san, you're worried about, your health insurance company charging you more. If what they want to do is that, they just need to go and look at your Facebook photos and see the size waist you have. Look at the photos and Instagram of the stuff you eat, whether you smoke or not. And they have there a much more clear and more predictable set of metrics to know likely how long you're going to live than what they can find in your genome, right? And it's much easier, by the way, to look at someone's photo on Facebook than to try to have a bioinformatician comb through, for the 150 gigabytes of data, right? So it is a concern.
That makes sense.
But go ahead.
No, it makes total sense. Go ahead.
Yeah. So that's, we do what we can. Will it happen at some point? Will somebody's database, either at a hospital, a company, an insurance company, be hacked? Probably yes. We can't expect it won't. We do what in terms of preventing it, right?
Okay, no, that makes total sense. So what's next on the horizon? Can you capture epigenetic changes to someone's genome, or is that like a whole nother ball of wax? Like what's next
you could
for Veritas?
No, that's a great question. So in the short term, meaning this year, look, the price of sequencing is going down. I think that's very clear. That's not news. The question is, how fast is it going down, right? So obviously our products will be more accessible to more people as the price goes down. We think, and Illumina, who's one of the main producers of the machines that do the sequencing, have said that, in 5 to 7 years, the genome will be $100. I think that's right. So the question is, what happens from today at $1,000 to, let's say, 5 years when it's $100? So that's price is going down. 2, we're launching new products. So this year we'll launch a newborn whole genome sequencing product with a report specifically for babies and children. So that'll come out too. I think you're going to see more movement in the industry. I think some of the players and we've been saying this for a couple of years, some of the players that are based their products on genotyping, I think they're going to realize that at a lower price, they probably need to move to exome or genome sequencing, right? I think that's also not news. I think that's expected. And then, the big one also is deploying these machine learning tools to hundreds of thousands of genomes, right? Our goal is to reach the 1 million genome sequenced in 2021. So it's in the next 2 years that we really can start deploying these machine learning tools and make some predictions and learn more about genetics. After that, you're right. It's on one side, can we understand more about epigenetics? And also other omics, right? It's proteomics and microbiome and et cetera, et cetera. So I think that's 3 to 5 years out where things are going.
Oh, are you going to be able to, or are you going to even try or attempt to sequence someone's gut microbiome or all the microbiomes in the person?
Yeah, I mean, there are companies already doing that. I think it's the integration of genomics with microbiome, with immune, with proteomics, et cetera, that is going to be sort of the next area, if you like, or the next frontier. So I think that's interesting. The other interesting aspect of what's happening now is, so today there are already many hospitals and clinics that offer whole genome sequencing for healthy people, right? So we have a collaboration with the Mayo Clinic, and they will offer our product, My Genome, in their executive health offers. So if you go and see your doctor at Mayo Clinic, you can ask to have your genome sequenced as a healthy individual, right? And use that information to help your healthcare plan. And there are, we have relationships with 30 other well-known clinics. I think part of what you're going to see this year is many, many, many more hospitals and clinics are going to adopt that. So probably in the next 2 to 3 years, you will see also every person that walks into a hospital will be offered like, hey, let's sequence your genome and see if there's information there to either treat you for what you're here for, or can we use that information to prevent certain things from coming down the line? So I think that's another trend that we'll see more emerge in the next couple of years.
Yeah, no, it makes sense. Do you think it may be a problem if genetic sequencing gets to be excessively cheap? What if it falls to, I don't know, $10 or $1? What would that do? I mean,
Yeah, look, the sequencing is quickly becoming a commodity, right? Eventually it'll be free, basically free, right? We ran a promotion in November. We decided to drop the price of our product, which is a clinical grade product, is the highest grade product you can find in the marketplace, to $199. And we said, look, we're going to offer 1,000 tests in 48 hours and see how many people buy them. Partly because, look, we don't have the marketing budget that someone like 23andMe or Ancestry, any of those companies have, right? We're a startup, right? So we have an amazing group of followers and supporters. And we thought, let's see, how long it would take to sell 1,000 genomes at $199. And we said 48 hours or 1,000, whatever comes first. We sold out in less than 6 hours. Half of them were gone by the time that, we started at 9 a.m. Half of them were gone by the time that, the orders from California were coming in, right? So the sequencing is quickly becoming a commodity. And the important and the difficult thing here is the interpretation, is what is the team that is doing an interpretation of my genetic code, of the differences, of the variants in my genetic code. And that's really where you can differentiate yourselves, right? And that's where you want to go. We sometimes use the analogy to Netflix, right? Netflix started offering shows that everybody else created, and you just paid for that access. But once you had Hulu and this and that and Amazon, etc., you could get access to all of that in different places. But now you have Netflix because of the content they create themselves. And that's why you go have Amazon Prime Videos, because the content they create themselves, right? So in a similar way, we're starting to create our own content, and we strongly believe that if we can give you the better interpretation for your results, you customer will decide to do it with us. Maybe the sequencing will be free, and then you have an interpretation, membership package, and you pay, $10, $20 a month or something like that. And we're exploring that, right? And we're pretty open about it. Why? Because that's where the value is going to come, is a relationship with someone for the rest of their life, for them to keep on learning from the genetics and then eventually, other aspects of their biology. I mean, that's the ultimate value proposition or service that we have for our customers, is come to us so we can give you the best possible knowledge about your genes and your biology for you to make some smart decisions about your health.
Well, so as not to make it a one-off, do you have a service where you're always looking at the latest scientific papers, curating them, and then, let's say, pushing it through a membership portal to the people that have had their DNA sequenced? So, you wouldn't want to say, because you have this predisposition towards this condition and we found new research on it. I guess it would be more an anonymous thing. But again, do you have a service like that, or will you have a service where you curate the latest science and it gets pushed to everyone and shows them what's new with genetic interpretation? Exactly.
That's what we're launching this year, right? So right now, the report that our customers receive is, we think it's a very valid interpretation of knowledge that is out there, that is in the literature, different studies, etc. The idea when we're starting this year is these regular updates, right? So today, the information that we provide to our customers, is a report that summarizes certain aspects that we think are important based on the literature and research, et cetera, that exists out there. We're starting to introduce our own content, right? So we have now a chapter called Risk in our latest report, and then it defines a certain particular types of genes that are related to certain conditions, and we give you what is a relative risk that you may have for. But where we're going now is creating these updates, right? Where maybe we start with a quarterly update in which we find what is the most interesting research out there in the literature, maybe our own research, and then we say, hey, there's some new insights, and we want to give those back to all our customers. But eventually where we want to go is it has to be much faster, right? This has to be, in a way, if you read an article on, the New York Times on Sunday about 20 new genes that are related to something that you're interested in, we want you to be able to ask us and say, hey, Veritas, can you take a look and see if I have this? Because I'm interested in this because of my Uncle Peter, whatever. And we should be able to literally turn around in less than 24 hours and say, yeah, here it is. It's in your report. Just log in, or here it is, right? Because at that point, it's literally just a search in through your genome, right? And maybe that's another $50 or something. We'll figure that out. But that's where we want to go. And then the ultimate final, if you like, or not ultimate, but the next frontier is your genome. Nobody wants to log into a report. Nobody wants to see a PDF, right? And we focus right now in a web interface, but where you really want to go is you just want to ask things of your genome like you ask things today of the weather, right? You want to be able to walk into Whole Foods and say, hey, is there anything in my genome around diet or something I need to keep in mind? And that's where you want the information about certain things that you might want to eat or not, right? Or you go to the pharmacy and you pick up your pills and you want to make sure that the medication that your doctor gave you you don't have a drug sensitivity for it because of your genes, right? It has to be immediately, it's in context. The information should be useful to you when you need it, how you need it. That's how we see, someone querying their genome. Not something passive that you have to log into and look at the report. That's like the 1980s. So that's where we're going.
When are we going to have, a relationship breakup where let's say the woman says, it's not you, it's your genome. I just can't.
I think we do that all the time. We just don't necessarily know what is genome versus not, right? And most of the time it's a combo. So,
You're like, sweetheart, we're just not genetically compatible,
Yeah. I mean, look, we know we do this today without knowing, right? There are many things we know that we find in a partner that are interesting or attractive to us, partly about what we perceive of them, and part of our ability to perceive is obviously genetic, right? We just don't know necessarily exactly where. But we're going to be learning a lot more of it.
Well, very cool. Well, last question. I've been learning a little bit about epigenetics, gene expression, and how that apparently changes throughout life. Do you think that you'll be able to capture gene expression so that I can be sequenced now and then in 5 years and then in 5 years, and I can see literally, okay, I have this base set of genes, but my gene expression is taking me in this direction and therefore predisposing me to this or that, or helping me avoid this or that?
Yeah, I mean, I think, yes. So epigenetics is one of those areas where maybe just a 30-second refresher is helpful for your audience, right? Epigenetics is information that is around the DNA, not in the DNA, that affects what genes get turned on and turned off. That's what we mean by expression, right? So I think we're going to learn a lot more about epigenetics in the next decades or so. We've just scratched the surface, not just in terms of your health and what happens to your biology, but other things, right? It's I did a talk earlier at TED in Vancouver this year, or last year, 2018, during a session called TED Unplugged, where I basically described that one of the possibilities with epigenetics is that some of the emotions that we have, positive emotions, moments of excitement in our life, this really, truly deep, those that happen a few times in your life where you just feel this incredible connection, whether you're looking at a sunset or you're enjoying a moment with a family member or somewhere in nature, etc. That some of those emotions might be a type of echo from emotions that our ancestors felt. That epigenetically is the way that we are experiencing it, right? And there's some evidence to show that it could be possible. I'm not saying that this has been proven, but I think we're going to find some really interesting things around what we today know about genetics. For sure, we'll learn a lot about genetics, but also other things that today, going back to the metaphor of the poet, today they sound like poetry and magic, right? And I think epigenetics is probably going to be one of them.
Well, this has been really fascinating. I mean, seriously. So what are some resources for listeners? I like a couple different levels. One is obviously, how to contact Veritas and get their gene sequence. And then another one is what can people read or experience that will tell them more about this?
Yeah, absolutely. So we actually created a whole series of videos. The first few of them don't even talk about our product or anything, but are more, sort of informational and educational, but they're well done. We partnered with a 4-time Emmy Award winner in Boston to work on these, and they're in YouTube under Cinema Veritas, or the Cinema Genetics channel has them. What is DNA? How are genes passed on? What is a variant, etc. So those are some basic resources. There are other resources on our website, veritasgenetics.com. We have additional videos, we have materials, we have articles, we have a bunch of blog posts where we try to explain everything from how big is a genome, to what can you find in a genome, to how do we compare with other tests, etc. And I think it's worth, look, we're not in the business of selling another test. There are many other companies doing that. Many companies out there just trying to make a buck by selling another test. That's not our business. We want to create a relationship with people long-term so they can really understand and learn more about their genomics over their lifetime, right? So I would suggest to your audience, take the time to read a couple of these articles. Take the time to see some of these videos. If you're asking whether to buy a genetic test or not for yourself or for someone else, I would ask 3 basic things. 1, what is the team and what are the qualifications for what they're doing? 2, what are the different privacy and security measures that they take? And 3, do they have support like a genetic counselor or someone that I can talk to if I have a question once I get my results? That's where I would start.
Well, very good. Rodrigo, this has been great. I think it's super interesting, and I think people will be very interested to hear this. So I appreciate you coming on the podcast.
Yeah, my pleasure. Thank you.
You're listening to the Future Tech Podcast with Richard Jacobs. Future technologies such as artificial intelligence, stem cells, 3D printing, gene editing, Bitcoin, blockchain, the microbiome, quantum computing, virtual reality, and exploring space are much closer than you might think. In fact, many early versions of these technologies are in play right now, and the companies that are using these technologies are the focus of this podcast. My goal for you, the listener, is to learn from these podcasts. You may very well learn something that may change the course of your life for the better, steer you towards a new career, or give you insight into addressing a thorny medical problem. Remember, this podcast and its content is informational in nature only. No medical, tax, legal, financial, or psychological advice is being given. If you enjoyed the podcast, please listen, subscribe, like, and tell your friends about it. Thank you.